Hello, good evening to everyone. Welcome to Unacademy, which is the biggest online education platform for GATE Computer Science and IT. Myself, Malesham Devasane, you can call me as Devas sir. Here I'm going to take a very special marathon session on identifying languages. So you know that in entire TOC there are three important languages we have: decidable, semi-decidable and undecidable languages, where in this class I'm going to talk about among these three. Along with this, I will also add the new languages like regular, CFL, DCFL and also other languages like finite and infinite languages too. So let me begin today's session with introduction to the Unacademy, where we are taking already many classes on Unacademy, where we have three types of classes. One, YouTube classes which are completely free, and on Unacademy we have two kinds of classes, free and paid. So we have so many free classes apart from YouTube on Unacademy too. So C, TOC, compiler and algo. So far I have taken so many free classes. More than 300 hours of content is available on Unacademy freely. Please go and watch them to have a practice and understanding of the concepts like daily practice problems and gate questions. Also regular classes on Unacademy free classes. So we call them as special classes. So please go and watch for these four subjects. And also, if you want to know about my profile before learning from me, I have completed my MTech from IIT Bombay. Then I have almost 12 years of teaching experience in taking the GATE classes. I'm teaching TOC, compiler, programming and other subjects too. Here I'm going to take 3 classes on this channel. So right now in this timing, I'm taking a theory of computation today. And this is my referral code where it will help you to get the subscription on Unacademy with 10% of a discount. Additionally, you will have guidance from me. Okay, the price of the subscriptions is going to increase soon from the 28th October. So please try to join as soon as possible if you are planning to prepare from Unacademy subscription. Okay, this is my profile where you can access all the classes that I have taken so far. www.unacademy.com/@DevaGateCSC. Yeah, I take Vinay from Monday. I'll continue back. Okay, fine. Sorry. If you are coming to the plus, you will have the benefits like live classes, live quizzes and tests, and crash courses, rank improvement batches and doubt solving courses separately, and daily practice courses and previous year questions, practice questions, various benefits from the plus subscription, and basically they are structured and scheduled properly. So you have two kinds of plans like plus and iconic. Plus, all the benefits I've discussed so far. Now iconic, apart from plus, you will have a coach to guide you all the time. You will have a plan, you will have guidelines to follow to guarantee that you will get the rank definitely. So here if you look at, there are two plans I'm talking about. There are two subscription plans. One is the plus for 1 year and another one is iconic 1 year plan, 40,500. So if you look at the difference, is 22,500 for plus 1 year and iconic 40,500 for 1 year, and that you require to use DEVALIVE code to get the same amount after discount. And if you want to choose the payment, you can go for credit, debit or net banking, including no cost EMI option. So if you have not joined our Facebook group yet, so please do that to get regular updates from us. And this is our Telegram channel. Unacademy GATE CS is our Telegram channel. You can subscribe to get material and notifications regularly. These are various free YouTube channels from Unacademy for various engineering streams like electrical, electronics, instrumentation, mechanical, civil and so on. And we have all free YouTube channels. Please share with your friends if they wanted to prepare. And this is the time to begin this class, guys. Please like the session if you are watching this video, and also subscribe if you have not yet done, and do share because we can reach more people. Thank you so much. Okay, let's begin today's session, guys. And my intention of this marathon is to give an idea of various languages. Like, you have finite languages, and you have regular languages, and also DCFLs and CFLs. Apart from this, you should also know decidable, like we call them as recursive languages, and semi-decidable, we call them as recursively enumerable, and another one is undecidable, but it is a very difficult word to answer directly. Okay, undecidable is one of the difficult word. Some undeciderables are within REL, some undeciderables are outside REL. So I'm trying to explain what I'm going to do in this class. Let me explain clearly about the discussion. So if you look at finite languages, finite and regular. Remember the relation before starting the problems. If anybody has forgotten the concept, you can recall from this diagram whatever I am going to discuss. Let me talk about, these are finite languages. Every finite language must be there inside this box. Finite languages. Another one is all regular languages, regulars. And this one, let's say DCFLs and CFLs and CSLs and recursive languages, recursives, also called as decidable languages. Now outside we have one more box, that is which is very important class in our TOC, that is recursively enumerable. These are RELs. And outside RELs we have not REL, so I'm not talking about that. Outside anything I take which is not RELs, not RE languages. Everyone, so when you look at this class diagram, you should know that every finite language is regular, and every regular is DCFL, every DCFL is CFL, every CFL is CSL, and every CSL is recursive, every recursive is REL, right? So this is the very important relation to identify the languages. But without knowing the theory of computation, whatever I do in the next 50 slides, it's very difficult to identify them, because you need to have a knowledge of construction of finite automata, DPDA, PDA, and little bit Turing machine. Okay, let's begin today's session, guys. Okay, first problem I will design now, then I will answer immediately. So today practice is going to be for 50 languages minimum. So I'm going to have a language. This is a language. So what you can say about this language? And so many answers for this. L is dash. Can I say about it is a finite language? Yes. So you can say about finite as regular, and it is DCFL. In the exam, you do not know what do they ask. It is CFL, and it is CSL, and also it is decidable, because a decidable another name is what? A recursive. And semi-decidable you can say, because it is REL2, RE language. So various very different number of names are there. So you should aware of all these names. I can call this L. Good evening, Ankit. I can call this language is finite, regular, DCFL, CFL, CSL, and decidable, also semi-decidable. So in the exam, we do not know what name is going to be asked. They may ask, is it decidable? Yes, you have to say it is decidable because you have a Turing machine for this, and its complement also have a Turing machine. Yeah. Guys, if you are enjoying my sessions, please like, right? So why we request all the time, right? We should dominate the dislikes because some people really don't like the free content on YouTube channels, but we are coming to you and to give the free sessions, and these free sessions absolutely useful for the preparation. So I want you to utilize and please like every session that you are enjoying from Unacademy. I want you to engage with us. We are here really to help you. Okay, please do that. So this is about the first language. Now let's go for the second language. Now let's look at how many names are there for this. L is, can I say infinite language? Obviously it is infinite set because there are infinite number of strings inside. And L is, I can say non-regular. Why non-regular, guys? Because you have a dependency over the symbols in the language. Yeah, good evening, Octavia. And then it is the DCFL. Why DCFL? Because you can design a DPDA, and that is what I am talking about. You should have an awareness of the construction too. It is a CFL because you can design a PDA for this, and it is a CSL. It is a decidable language. Why decidable? Because it is already recursive. Every recursive language also called as decidable language, and it is semi-decidable because you have a Turing machine for this. You can call RE, recursively enumerable language. We have many names for this language. Everybody, guys, so look at how do we understand the language. You can call this is infinite language because there are infinite number of strings, and it is non-regular because you can't design a DFA, and it is DCFL because you can design a DPDA. So after this you can use the class diagram to answer it. Right, so far everything is clear? Fine. Third one. Now I'm assuming over A comma B, sigma always fixed for every language. Now what is L is? Can I call finite? It's not finite, so I can say it is infinite because infinite strings are there. And what else I can call now? L is non-regular. It is a not regular or non-regular. Why? Because you don't have a finite parameter for this. Can I call DCFL? It is also not a DCFL. Why not a DCFL? Because you don't have a DPDA for this. But it is, no doubt, it is CFL. Everybody, it is definitely CFL, context-free language. Why context-free language? Because we have a PDA for this language. And so I can say it is CSL. Everyone, I can say it is a recursive. You know, recursive language also called as a decidable language. In MSQ questions, you might be asked such things. Yeah. And have a good practice on answering these questions. You can say RE language because recursively enumerable, but we have another name for RE, that is semi-decidable. So I can call this language as decidable, also semi-decidable, but you can't say undecidable because already they're inside decidable. Yeah. When you look at this one, what is the exact name you can give using the class diagram, guys? L is CFL, but not DCFL. Remember that, guys? This is the exact name where the L exists in the inside the class diagram. If you look at the class diagram, I'm going to talk about this one. The language is definitely here. Here infinite languages are there. This language is called as CFL but not DCFL. Everyone? Yeah, this is third language. Now we'll go for fourth one. A power n, B power n, C P power n. I'm trying to increase the complexity, guys, so that I can ask randomly later on. What is this? L is dash. What you can answer about this language? I can say infinite, no doubt, but also I can say it is not CFL. And you know that not CFL means it is not regular, not DCFL. I have answered indirectly here, guys. It is a not regular, I have answered. Indirectly not DCFL, I have answered when I answered not CFL. Outside the CFL class means indirectly outside the regular class, outside the DCFL class. Yeah. Now, what else I can answer? It is no doubt CSL. So, I can say recursive. It means decidable. Because of recursive, it is RE language. So, I can say semi-decidable. Everyone, so this many names are there for the same language. What is the best answer for this? L is dash. What is the best answer, guys? CSL but not CFL. This is the best name you can give for this language. But if you want to answer this language, CSL, or you can say recursive but not CFL. Okay, guys, please like this session. If you are watching this video and if you are on live, please do like the sessions. It's very important to reach. Okay, thank you so much. Thank you so much. Do not forget. Okay, next one. Now, this is a very interesting language. Now we are saying, guys, now saying regular is difficult. You can't say regular now. The language first we need to understand. What is this means is, it's not one DFA. Set of all DFAs where each DFA accepts empty. Where each DFA accepts pi. Means empty language. That means each DFA accepts nothing. Now what is exactly this language, guys? Every DFA you can understand is it empty or not without taking exponential space. You can take polynomial space on every DFA to understand whether it is accepting empty or not. So here it's a very difficult to say. Now you can say this language is definitely not finite. It is infinite, no doubt. But this infinite is not over sigma. But I'm not talking about this finite infinite because it's difficult now. Such languages we will ask about decidability. We don't ask even context sensitive. It is a context sensitive, but very difficult to say now context sensitive, because if you want to understand is it context sensitive problem or not, how much space it takes on every DFA to understand every DFA accepts empty or not empty. Right, guys? So this is definitely context sensitive, but we'll talk about from decidability. It is a decidable, no doubt. Why it is decidable? Because this is emptiness problem. Emptiness problem. I can check. How do you know it is decidable language, guys? Every DFA has an algorithm. So we have emptiness algorithm. Emptiness algorithm. It's emptiness problem. Emptiness algorithm can run in polynomial time by taking polynomial space here. But I'm not talking about that algorithm now. Just you can convert to context-free grammar and check whether the context-free grammar is empty or not after simplification, something like that. So this emptiness algorithm exists on every DFA. On every DFA, you can apply this. So it is decidable. I have an algorithm to say yes or no. Okay, so that is the reason L is decidable. So I can say now in the exam you do not know, this may be asked as semi-decidable. Yes, every decidable is semi-decidable. I can say that. I can say that. I can say it is a recursive language. I can say it is recursively enumerable. All names are same because L is best answer is decidable. Then I can say decidable is, I can say semi-decidable. Another name is RE, but decidable another name is recursive. Yeah. Look at guys, the best name is actually context sensitive language because it's outside the syllabus for us. So I'm talking about a recursive language or not. This L is recursive. L is what? L is recursive. L is recursive language. Remember that L is a recursive language. You cannot call this is a regular, you cannot call this a CFL, you can't call it DCFL. This is the best name is recursive language, right? DFA is designed over sigma, but L is not over sigma. Remember that. Both are different here. Both are different here. L is different, DFA is different. Yeah, let's move on. Let's move on. Now onwards, the problems are slightly difficult, so we are going to quickly finish this. Now I'm just going to talk about regular expression, where regular expression generates, let's say, AB. It's just a membership problem, guys. It's just a membership problem. Whether the given regular expression generates AB or not. So regular expression you need to convert into DFA. Then GFA we need to verify the membership algorithm. So here you may take exponential space. That makes time basically. Okay, don't worry much about it. Now this is a decidable language, but it is not a regular language, guys. It is decidable language, so you can call recursive. Even it is not a context-free language. It's a basically what is L, guys? L here it is not one regular expression. It is set of all regular expressions where each regular expression generates AB. Generates string AB. Yeah. Carefully understand, guys. It is decidable, so I can say it is, even it is RE language. So I can say even semi-decidable. Every decidable you can say semi-decidable, but you can't say semi-decidable is decidable all the time. Remember this point, we are talking one direction. If you already know it is decidable, you can say semi-decidable, because in the class diagram every decidable is semi-decidable. Keep that point, do not forget. Which algorithm you can use? Membership algorithm. Remember that. How do you know it is decidable, guys? There is a membership algorithm exists to decide this problem, whether the given regular expression generates AB or not. Okay, seventh one. L is equal to left linear grammar. I'm going to collect left linear grammar where each LLG generates AB. So each LLG is designed over particular sigma, that's okay. Now, it's nothing but set of left linear grammars where each left linear grammar where each LLG generates AB. And again, this is which problem, guys? Membership problem, right? It's a membership problem. Like language generated by LLG has AB or not? It's a membership problem. You can use the CYK algorithm to verify this problem. That also takes polynomial time, and by it also takes polynomial space, no doubt. This problem you can say it is context sensitive language also. So now I'm going to talk about this L is. I'm not talking about LLG, remember that. I'm talking about language. L is a decidable language. So I can say it is recursive. So even I can say this decidable is RE language. So I can say semi-decidable. But do not say undecidable now. Yeah. No, Verma, that's wrong. Guys, that's one of the mistake that we do. Look at the diagram here. Guys, please understand one more time. Do not use the words blindly. I used to do the same thing. Please don't do that mistake. And if you don't know the relation, first know the relation. What I am trying to say, guys, these are all decidable languages. Even problems also same relationships. These are all semi-decidables. Now what is the relation we have? Every decidable is a semi-decidable here. Remember that. Every decidable language is semi-decidable. But semi-decidable need not be decidable. But what is this problem now? They are semi-decidable but not decidable. Remember that. These are very special. All semi-decidables only called as all RELs. Decidable, another name is what? Decidable, another name is what? Recursive. Decidable, another name is what? Recursive. And semi-decidable, another name is what? Recursively enumerable. So please have the synonym with you before. If every recursive is recursively enumerable, every decidable is also semi-decidable because they are synonyms. But this is all RELs, but they are recursive but not recursive. Means but not decidable. Everyone, guys. And who is undecidable here? From here to outside, these are undecidable. These are undecidable languages. In the undecidable, semi-decidables comes, even not RELs comes. Here to here, who is there? Not RELs. So if you are not aware of this, please keep that words first. Semi-decidable is not, what is that? Not always undecidable. Semi-decidable is two types, decidable and also undecidable. Everyone, guys? Everyone, come on. Semi-decidable is two types. Here, decidable is also semi-decidable and some undecidable. Not every undecidable, guys. Some undecidable, because some undecidable even not semi-decidable. Okay, that some undecidable problems are semi-decidable, but every decidable is semi-decidable. Okay, good. So remember this point. Now when it comes to undecidable, guys, undecidable, you can say every semi-decidable is undecidable. No. Not every. Some semi-decidables only. Some which are there outside. Some semi-decidables are undecidable and every not REL, outside REL is undecidable only. Look at that. In that some semi-decidable, who is that? Outside decidable only. Okay. Please have relationship before answering. Do not confuse with the words. Already the problem, answering the problem is difficult. You are confused with the words. Really very difficult for you. Okay. Have that relationship carefully. Don't say every semi-decidable is undecidable. Remember that. Okay. Already I am saying decidable is semi-decidable. Then how can you say semi-decidable is undecidable? Don't say that. That depends on the problem. Okay, come on, guys. 8-1. Now DFA1, DFA2. Language accepted by DFA1. Language accepted by DFA1 is equal to language accepted by DFA2. Now what is this problem? This problem is equivalence problem. Is that equivalence problem decidable or not? Yes. For every given 2 DFAs, equivalence is decidable. Now you can ask any pair in the world. I can verify using the same algorithm. So L definitely L is decidable. So I can say L is even semi-decidable. But don't say undecidable, that's wrong. Semi-decidable I am saying means I am saying RE. Decidable I am saying means I am saying recursive language. Yeah. Everyone? So you should know now what is the algorithm for two DFAs are equivalent. So what is the algorithm you can use? You can minimize the two DFAs if they are isomorphic to each other, right? If they are exactly having same structures except the state names, then definitely they are accepting same language. Okay. Ninth one. Now sometimes we may ask, one is the DFA, other is left linear grammar or right linear grammar, anything doesn't matter. Language accepted by DFA is same as language generated by LLG. Then again this problem, you can convert left linear grammar to finite automata too, right? This is again same problem, equivalence for finite automata only. Equivalence for regular languages is decidable. I'm giving you two regular languages. You want to check whether two regular languages are same or not. Yes, you can convert into all of them into minimum DFA. You can check that. So it is again decidable. L is decidable. So I can say that even L is semi-decidable. But do not say undecidable yet. We can't say undecidable now. Yeah. Any doubt, please keep posting it. And if you are not yet like this session, please do that. Please do that. Like this session. Okay, 10th one. I'm going for very interesting problem. This is R1, R2, where R1 and R2 are regular expressions. And I want to check language represented by R1 is same as language represented by R2. Now, this is the special language, guys, in the world, and this is not a context sensitive language. Remember that. We don't have in the syllabus, but it is. So far, the previous languages some of them are context sensitive, but this is a context sensitive language. Why? Because to verify two regular languages are equivalent or not, that takes exponential space for the single pair. But it is decidable because we have an algorithm. Even though it takes exponential space to decide, but we have an algorithm. L is decidable language, and that is the difference. If you wanted to know any language that is not a CSL but you want to say recursive, this is the best problem. I can say this problem is L is a recursive language but not a CSL. The best language about, but as I'm telling you, these problems are slightly difficult, so you can remember this problem. If any question comes in interview, you can disclose this example to say that why this language is a decidable but not context sensitive. The reason is to verify two regular expressions are equivalent or not, which takes exponential space. But as you know, linear bound automata, the space must be linearly taken, but this takes a more than linear, that's exponentials basically. Okay, but if you go on, L I can say is semi-decidable because already decidable. Every decidable I can call semi-decidable. Okay, so these are the important answers so far. And I'm keeping the star marks for the 10, which is very interesting language. Okay, 11th. Now I'm going for DPDA, where language accepted by DPDA is not equal to pi. Means which problem, guys? This one is non-emptiness problem. You know, emptiness problem already decidable. So if emptiness is decidable, non-emptiness is also decidable. If I know how to check whether the given DPDA accepting non-empty language or not, then definitely I can collect every input if it is not accepting empty language. So L is, I want a set of all DPDAs where every DPDA accepts non-empty, means accept something. Okay, so it is also decidable. And here it can be context sensitive language, because verifying this emptiness takes polynomial space. Then definitely you can say that a linear space. So I can say that it is going to be linear bound automata. You have it. To understand this problem, you have a linear bound automata. So this is a decidable language, but also CSL, remember that. So I can say that semi-decidable. But you can't say this is not a DCFL. This is not a DCFL, not CFL. It's not one DPDA, it's a set of all DPDAs. It is not CFL. Yeah. Verma. Algorithm. The words, guys, anybody not aware of that? Algorithm means halting program. You have halting program means it is a recursive problem. Recursive means decidable. Decidable problem means you have a Turing machine that always halts, and these all words are same. And when somebody says I have a program, means need not be halting. It is just recursively enumerable. A problem is recursively enumerable, means I am saying it is semi-decidable. I don't know whether I halt for invalid strings or not. So simply it is enumerable. And I can say just I have a Turing machine exists, that's all. I can't say HTM exists or not. Everybody, so these are the important words, Verma. Anybody else is having doubts, have a clarity on these two columns. Algorithm means my problem is decidable. Program means I have a program, I have a logic only for valid strings, means I'm talking about recursively enumerable. Okay, everybody. So these two words you should use carefully. Algorithm exists means that problem is decidable. Everybody, guys, algorithm exists. The word when I use algorithm means I have an algorithm for this problem. That means that problem is decidable. Okay, so do not change your meaning of the algorithm. Algorithm definition is we have this set of instructions where it can execute infinite amount of time. The time never takes infinite. That's algorithm definition too. But program can take infinite time. But algorithm, what is the difference between algorithm and program, guys? Every algorithm you can assume it as a program, but program need not be algorithm. Program never be algorithm if that never halts in some cases. Yeah. Everybody clear that point? Here, what is the relationship between this program and algorithm? You can theoretically, I am relating, guys, theoretically. Okay. Every algorithm is a program, but program need not be algorithm. But program need not be algorithm. That is the most important word here. Then which programs are algorithms? Those programs which always halts, they are algorithms. So whenever you are studying algorithms, in that sense, you have the cases that it always halts, whether the string is valid or invalid. Okay? Exactly. When I don't have an algorithm, that problem is undecidable. But that may be semi-decidable, that may not be. Right? So Sweta Pandey, it's right. But some undecidable problems are semi-decidable, some are not semi-decidable. Two things are there. Semi-decidable word is very dangerous here. Come on guys. Is that clear? 11 problems are over. Let's go to 12. Okay. What is the meaning of this? The meaning is it's not one DPDA, set of all deterministic machines where each DPDA accepts finite language only. So any DPDA which accepts finite language, that we need to identify. Everybody, then do you have any algorithm for finiteness? Yes, finiteness problem is already decidable. right? Note, we have an algorithm whether a DPDA, or I can say whether language of DPDA is equal to finite. This problem is decidable. This problem is decidable. Right? You can ask any DPDA in the world. I can show, I have an algorithm I can apply on that DPDA. That is, you know that you can draw a dependency graph after converting into context-free grammar. So the dependency graph will tell you whether the DPDA is accepting finite language or not. Okay. So now this problem is also, L is also decidable. Because problem is decidable to verify DPDA, we have an algorithm. Why we say decidable? Because algorithm exists. Which algorithm? Dependency graph. Draw a dependency graph for every DPDA by converting into CFG. Dependency graph exists to verify finiteness or infiniteness. Doesn't matter. Both can be verified. Yeah. Yeah, Dilip Singh, anybody is having any question, I will take up that question. Please keep on posting your questions too. I will take that questions out of 52. That is the advantage of this session, guys. Any doubt you have, put in the chat. I will take that question in a sequence. So L is decidable, so I can call even L is semi-decidable, because every decidable is semi-decidable. So in the exam, if they ask L is recursive, correct. L is recursively enumerable, correct. L is decidable, correct. L is semi-decidable, correct. Because already you know it is decidable, so you can answer all of them. Everybody, but you can't say now L is undecidable because it's already decidable. Yeah. Now 13. I'm increasing the complexity. So Dilip Singh, I will take your questions just after a few questions. So wait for your turn. Sweta Fonde, don't answer anything that you have. For semi means, I'm already saying, guys, every decidable is semi-decidable now. Then how can you say there is no logic? Every decidable is semi-decidable. Decidable means recursive, another name. Semi-decidable means it is recursively enumerable, another name. Every recursive is semi-decidable, then how can you say semi means no logic? Semi-decidable means we have a logic for valid, but we don't know whether we have a logic for invalid or not. What I'm doing, Sweta Ponde, what you're doing here, use the relationship. You don't know what is semi-decidable. When will you start answering these questions? Very, very difficult, guys. Those people who are not good at the words, you can't answer these questions at all. First, have a clarity on what is decidable, what is decidable. Guys, anybody not having awareness about this, from Monday onwards, undecidability chapter begins. This Monday onwards, please continue from Monday for 5 days to understand what is decidable, what is semi-decidable. These words, when you don't have a clarity, you will always have a confusion. Yeah. Now 12. You watch these videos again once you have a clarity on the definitions. 13. Now let me move to the PDA. I am talking about a PDA where PDA accepts epsilon. What is this, guys? This is called as membership problem. When somebody is accepting some string, some machine accepting some string, it's a membership problem. Membership problem. Then is it a decidable or not? Membership problem, you can use CYK algorithm exists. CYK algorithm exists. If algorithm exists, that problem is decidable blindly. So on every PDA I have an algorithm. So you can ask any number of PDAs in the world. I can verify whether that PDA accepts epsilon or not. So this L means set, not one PDA. Remember, every PDA, set of all PDAs where each PDA accepts epsilon. Right? So I can here note why this problem is decidable. Whether given PDA given PDA, one PDA you have an algorithm, whether given PDA accepts epsilon, this problem, this is a problem, this problem is decidable problem. So using this algorithm, why decidable problem? Because algo exists. Using this algorithm, I can verify on every PDA, I can halt always. So now I can say that this is a decidable language. L is a decidable language. I'm using two words, language and yes. Yes, Sweta. Okay, if it is decidable, so I can say L is semi-decidable too. Wait, so far I am not using undecidable word, right? Yeah, good point, guys. Look at algo not exist. Algo not exist. It means we may have a program, or we may have Turing machine sometimes, or we may not have. Don't worry about program. Say TM. We may not have TM. When algo not exist, if algo not exist, if we have TM, that means it is very special, semi-decidable, no doubt, but not decidable. And this one, even you can't say semi-decidable at all. This is not a semi-decidable. You can answer not semi-decidable. It's not semi-decidable. Definitely, it is not decidable only. These both problems are undecidable. This and this both are not decidable. Undecidable. What is another name? Not decidable means not recursive. Outside recursive. That means not recursive. Outside recursive. Even though you have a Turing machine, but you don't have halting Turing machine, it means no HTM exists. When I don't have HTM, you may have a Turing machine, you may not. Come on. Don't say when there is no logic. How do you say? You say algorithm, don't say logic. Logic means logic. Are you talking about valid or invalid? Don't misunderstand the words. You just need to stick to the definition. Why are you talking about logic, semi-decidable, undecidable? Why are you confusing by looking at so many words? I don't understand why are you speaking this many words at a time. Have a particular definition with you. Do you know what is the logic definition? Why are you using the logic? So I'm talking about algorithms. Algorithm will talk about logic for valid, logic for invalid. Do you know what is algorithm exactly? Let me explain. I'm saying algorithm means the particular problem has the logic for yes, logic for no. That is we have to say. Don't say logic just word. Logic exists for yes, logic exists for no. Then only we say that algorithm exists for this problem. Right? Just don't say logic word. Logic, what is the logic means? Algo exists for the problem or not? This problem, yes, I know you are able to answer it. That means algorithm exists for this problem. This problem, we have logic for yes, I know. Then we say algo exists. Logic only there for yes. That is just we have a Turing machine. Look at guys, algo exists means you have to show the logic is there for both yes and no. Why are you speaking? Logic exists for both yes and no. Logic exists for valid and invalid. That is the meaning. Invalid members. Not one to every. And if you are saying logic only exists for yes, logic exists only for yes, and no, you are not able to say because logic not exist. Logic not exist, I am saying it. Then that problem is strictly semi-decidable. That is semi-decidable but not decidable. Don't say just semi-decidable. Semi-decidable but not decidable because outside recursive. Here we can't say algo exists. Only we can say this problem TM exists. But previous problem, algo exists means HTM exists. So definitely TM also exists. So that is the reason I can say semi-decidable also. This is a decidable. This is a decidable. Every decidable is also semi-decidable. But semi-decidable doesn't mean that decidable. Look at these two problems, guys. सेमी डिसाइडेबल राहुल, क्या दुनिया में सो क्या आ रहा है क्या? सेमी डिसाइडेबल मीन्स रिकर्सिवली एन्यूमरेबल, अनदर नेम, अनदर नेम, अनदर नेम। क्या शुरुआत से आ रहा है, नहीं आ रहा है? बीच में आके क्वेश्चन पूछ रहे हैं क्या? ये पढ़ लेना। सेमी डिसाइडेबल मीन्स अनदर नेम इज रिकर्सिवली एन्यूमरेबल। आपको पता है ना रिकर्सिव एन्यूमरेबल मतलब ट्यूरिंग मशीन एग्जिस्ट। कोई भी दुनिया में ट्यूरिंग मशीन एग्जिस्ट है, उस प्रॉब्लम को सेमी डिसाइडेबल बोल सकते। वो जो डिसाइडेबल है नहीं है हमको मतलब नहीं है, दैट इज द सेमी डिसाइडेबल। बट ट्यूरिंग मशीन है वो सेमी डिसाइडेबल है। एवरीबॉडी गाइस, राइट? इफ यू आर कमिंग इन द मिडिल, राइट? एवरीबॉडी क्लियर? एवरीबॉडी, आपको वर्ड्स को याद रखना है पहले। अगर दुनिया में वर्ड्स याद नहीं है तो डेफिनेशन भी याद नहीं रहेगा। क्यों? यू नो व्हाट इज रिकर्सिव एन्यूमरेबल, then you don't know what is semi-decidable. What is the meaning of that? When you know the definition of recursive enumerable, then semi-decidable is also same now. Why are you worried about it? You are not able to interconnect these two words. I am telling you, you are not able to answer the questions. Means first you are not able to understand the words. Everybody guys, पहले इस लाइन्स को देख लो, क्या बोल रहा हूं? एल्गोरिथम, रिकर्सिव, डिसाइडेबल, तीनों वर्ड सेम है, तो कंफ्यूजन क्या है आपको? Right? Semi-decidable, another name only recursive enumerable. You know recursive enumerable definition, but you are not saying what is semi-decidable. ये क्या होता? यही तो है ट्यूरिंग मशीन। मेरा पास ट्यूरिंग मशीन है, इस प्रॉब्लम के लिए क्या बोलते हो उस ट्यूरिंग मशीन को? That ट्यूरिंग मशीन is accepting semi-decidable language. Why? Because recursive enumerable, another definition only semi-decidable. Clear this point, guys? Anybody is not understanding this slide, look at carefully how to learn it. I have a Turing machine means that problem is semi-decidable. But same problem you may have halting Turing machine, then same problem it may be decidable. But if you don't have halting Turing machine, then I'm telling you one thing. I have a Turing machine for particular language L, then what can I say? What can I say, guys? Implies L is, I can say, semi-decidable, that's all. Or I can say recursively enumerable, that's all. Why are you not able to say decidable? Because I don't know whether halting Turing machine is there or not. If you disclose what is L, I will verify. Are you clear? I have just a Turing machine, then I have a very clarity that is, it is a semi-decidable. But when you know that I have halting Turing machine for L, then I can say that L is recursive. That means L is decidable. But now, can you say regular? Can you say CFL? Can you say DCFL? No, I can't. Now you should know about L. L may be regular. So L might have an even finite denominator. So be careful when you answer such questions. I have halting Turing machine. That means I can say recursive, that's all. Or I can say semi-decidable, because every recursive is what? I can say even L is semi-decidable now. L is REL, I can say, because I will also have a Turing machine, because every HTM is a Turing machine. Look at this point, guys. Here, previous one, L is semi-decidable, but we don't know. By looking at this theory, we don't know whether L has HTM or not. When we know it, we will decide the answer. So understand the words. Do not assume yourself anything. Okay, let's move. Okay, 13 problems over. Okay, 14th. Keep posting your questions. I will take one by one after 20 questions, guys. Before that, let me explain whatever I want. Okay, first let me discuss this 20 questions first. Okay, now PDA1, PDA2. Language of PDA1 equal to language of PDA2. Look at the first time I'm introducing this word to explain you something about a PDS. This is the equivalence problem. So equivalence problem is undecidable, we know. So we can answer this is undecidable, but not a clarity. L is, everybody knows in the world, it is undecidable. But now what is it? Undecidable languages are two types. Now you should have a question to yourself. Is it semi-decidable or not semi-decidable? Is it semi-decidable or is it not semi-decidable? That you should answer now. Because in the exam, sometimes they don't leave with just undecidable. Because undecidable, maybe, let me explain. If all decidables are here, all decidable languages are here, then outside everything is what? All not decidables only. All not decidable languages means all undecidables only. It means in that two classes are there. Up to here, you may have all RE languages, that is semi-decidables, all SDs. So that means these languages, some are inside SD, some are outside SD. These are not SDs. Everybody? But here to here, we have all SDs. Now we have two things. Is that undecidable problem inside SD or outside SD? But definitely that is outside decidable class. Clear this point? Now we know the problem exists here, guys. The problem exists here. We know undecidable, but which side it is? Inside SD or outside SD class? Now we need to answer that question. We need to answer that question, guys. Now look at that. If you want to verify two PDAs are equivalent, what is the problem you have? What is the problem we have? Now we need to build a logic. Look at that. We need to build a logic. You have given a pair PDA1, PDA2. And such pairs I am going to give infinite inputs. But one input, do you have a logic first? What you have is L of PDA1 equal to L of PDA2. This is an equivalence problem. Yes means what I have to prove, guys? I have to show equal. They are equivalent. Accept same language. Accept same language. No means not equivalent. Not equivalent means they don't accept same language. Then what is the key point? Do you have a logic for S? Do you have a logic for S? If they want to equivalent, if you want to show equivalent, like you don't have algorithm like DFS you can minimize, you can check the structure. But in PDA, there is no structure verification. So what we have, every string both should halt at final, or every string both should halt at non-final. So every string you given, both the PDA should halt at final or both should halt at non-final. But every string we can't verify. So this has no logic at all, because we can't verify every string because infinite strings are there. But no, do you have a logic for no? Not equivalent means I can show that some string, one PDA halts at final, other PDA halts at non-final. Means one PDA accepts, other PDA doesn't accept. You can use a CYK algorithm to verify this. Right? Every string you will apply for CYK, and if one machine says yes I am accepting, other machine says not accepting, that means you found they are not equivalent. But if they are equivalent, really you don't know. So here, no, S has no logic. S has no logic means it is purely not REL problem. Guys, it is not semi-decidable because S has no logic. When S has no logic, sorry, not here, I'll write here. Semi-decidable, it is not semi-decidable because S has no logic. Is it not semi-decidable? Yes, because no become S. Yes, not semi-decidable, S has the logic. How do you know that? Because no of semi-decidable is S of not semi-decidable. Remember that? So it is not semi-decidable means it is not REL. Clearly I can say not a semi-decidable, not SD. Guys, be careful when you use these words. Look at, do you have S has a logic or no has a logic? Just you require to verify yes or no. Here, if yes has a logic, it's definitely semi-decidable. If no has a logic, its complement is, are you clear? Is semi-decidable, not this one. So understand, here S has no logic, that's why I'm going for not semi-decidable. Not semi-decidable. Everybody guys, why this is not semi-decidable? Because I don't have a logic for S. And I want you to, I want you to remember this. Whenever I say decidable, yes and no, both will have a logic. Remember these words, then only you can answer. Logic exists. Everybody? And when I am saying just a semi-decidable, yes, definitely have a logic. And no need to speak. Because no may have a logic, no may not. That depends. No, it's choice. Logic may exist. May exist. Because every decidable already semi-decidable, or logic not exist. That's okay. If logic not exist, look at that guys. If logic may exist, that is decidable problem. If logic not exist, that is not a decidable problem. Then semi-decidables are two types. One is decidable, other one is not decidable. Inside there are two types. Okay, but when I am saying undecidable, this word is very dangerous. Undecidable guys, I don't know exactly yes will have a logic or not. Yes, two cases. If it is semi-decidable, yes has the logic, and no will not have a logic. No logic exists. No logic for no. Okay, confusion with the no word, so let me write. Logic exist, logic not exist. Logic not exist. This is one kind of undecidability. If this is not, what will you find guys? Yes, no logic exist, or simply write logic not exist. That's all. That's all. Logic not exist. When I am saying S has no logic, then that means it is purely outside SD. This is SD problem. This is not SD. SD but not D. This is not SD. Right? And not REL. The other word when I use, understand, not REL. What is the not REL means? Not SD. What is not SD? Yes itself has no logic simply. Logic doesn't exist for S. And this words plays a lot of important. You don't know the words directly, you are coming for decidable, semi-decidable, undecidable, you will never understand the answer. Logic not exist. I am always worried in the beginning of my classes. Yeah. When you don't have logic for S, it's purely outside SD. Means undecidable, also not SD. Understand, remember these words. These are the definitions of words I am talking about. How to speak a decidable problem or language. This is the most important part of undecidability chapter guys. Are you clear about these four words? One more word that is undecidable but SD. Undecidable but semi-decidable. Who is that? Yes has logic and no has no logic. In that sense, we can say it is undecidable. Why? Because SD, because S only has a logic. Everybody? So keep these points already covered in the undecidable two definitions, but I am writing. So remember these three definitions, 1 and 2 and 3. These three will play very important role for you. And maybe 4th you can understand later, 5th you can understand later. So whoever can remember these 5 definitions, for you it will become very easy to identify the languages. Clear this point? Okay, let me start the problems again. Okay, previous, where is that? Now, is this clear? It is undecidable, everybody knows in the world, because equivalence, no algorithm exists for PDA. But which undecidable? This is purely not semi-decidable. How can I answer now? L is UD, undecidable, and also not SD. UD and not SD. Come on, keep on going one by one. Look at how much time it takes to answer one question. But once you know it, it will just take seconds to answer the question. Okay, now let's move to the Turing motion. TM accepts, let's say A, B, B. What is this question? Is it membership problem or not? But we know membership is undecidable. But exactly you should know which undecidable it is. Then only you can answer correctly. Everybody knows in the world L is undecidable. But undecidable, there are two types. Is it SD or not SD? You need to answer now. What is exactly inside undecidability? Okay, now we need to verify. I'm coming for this. First, do you know whether TM accepts any W is okay? Particular W. What is this problem? Which one has the logic? Yes or no? Which one has the logic? Based on that, I can answer this question correctly. S means that Turing motion halts at final. Definitely halts. But no means we don't know. We don't know what it does. We don't know whether it halts or not. Because there are two cases. It can halt at non-final or it can never halt. Both answers are there here. So no, I can't guarantee whether I can say or not, because it may enter infinite loop that never stops. So which one can stop all the time? Yes has the logic. Because it always halts at final. No, we don't have a logic. We don't have a logic. Because we don't know when it halts. That means this problem, membership problem, is a semi-decidable and undecidable. SD means semi-decidable and also undecidable. It is outside decidable but inside semi-decidable. Everybody class? Everybody guys? So this is UD and also semi-decidable. Everyone? So this problem is semi-decidable now. So you can write in a bracket undecidable but partially semi-decidable. But is that every undecidable is semi-decidable? No. Some undeciderables are not. Same question I am talking about guys, a different way. So now this problem I can say L is recursively enumerable. Why guys? Because every semi-decidable is, another name is what? Recursively enumerable. Only name is semi-decidable. But L is also not decidable. Means it is outside decidable class but inside semi-decidable class. Clear this point? Now let's small change to this problem. Let's look at who can answer it. L is equal to TM, set of all Turing motions where every TM doesn't accept ABB. Now, which problem can solve this question? First, you should have algorithm on one TM, whether TM does not accept ABB. This is my problem now. This problem, yes, no, you should understand. Then only you can answer this question. This is not a membership problem. It's not a membership, guys. The problem is not membership. Membership is different. Not membership is different. Okay. S means ABB not accepted. Not belongs to language accepted by Turing motion. No means ABB belongs to language accepted by TM. Okay, that means TM doesn't accept ABB. TM does not accept ABB. Here TM accepts ABB. First guys, do you know how to verify the given string doesn't accept? Because TM is given, string is given. If suppose does not accept, what can happen? The Turing motion, you may enter infinite loop that never halts basically. It might happen. Look at this one. No logic to verify. No logic to verify. Why? Because TM may enter infinite loop. Because TM may enter or TM may never halt. We know guarantee because it's not HTM. It's not HTM. Halting Turing motion, it always halts. You can verify. Yeah. So focus on what? When S has no logic, don't verify for no guys, because I didn't ask you complement. Don't worry about no. When will you worry about no? When you have S has a logic, then go for a no. Because if no also has a logic, then S and no will have a logic. then decidable. When S has a logic but no has no logic, then it is a semi-decidable but still undecidable. And when S has no logic, don't worry about no at all. Now directly you can say this problem is undecidable. We know already. But is it not semi-decidable? Yes. L is not REL, you can say that. Or simply not REL means not semi-decidable. Right? Most of the people, they confuse not REL and not SD. They are synonyms, guys. When I am saying not REL means not semi-decidable. Everybody? It's the most important point for you. Yes? Okay. Let's move. 17th problem. M such that M is a Turing machine and language of M is equal to pi. And what is this problem, guys? Emptiness problem. Emptiness problem. Emptiness problem, we know undecidable, but we should know now what is this emptiness. Okay, what is this emptiness? Is it semi-decidable or not semi-decidable is very important word. Everybody knows in the world L is undecidable, but that's not enough. Everybody will not ask just undecidable. Is it really? Which is right? L is it semi-decidable or not semi-decidable? Here you need a logic. Now guys, whether TM accepts pi, empty language, this problem we want. Here input is a Turing machine. Now S, I know you have to verify. Who will have a logic? S means every string is rejected. Of course, one string is rejected. We don't know logic, guys. Previous problem. ABB, whether it is rejected or not, we don't know. Now every string is rejected. In sigma star, no logic at all. But TM doesn't accept pi means TM accepts something. TM accepts some string. No means that is will have a logic. How, guys? Logic exists. How do you know that the Turing machine accepts some string? What do you do, guys? Let's say I have a Turing machine. Ask epsilon w1 in lexicographical order. Same copy TM, copy the same TM. It's like a thread concept. Apply W2, same TM, copy the same TM. Apply the W3. If any of the Turing machine, any TM accepts some WI, because particular W only, right? We are talking about particular W only. If any TM accepts W, then that TM alls at final. So we can stop all logic. We can stop the whole program. Okay, if the TM accepts some string, we have a logic how to verify. But if TM doesn't accept any string, no logic. That means no has a logic. But in case every TM is going to infinite loop, that is maybe TM doesn't accept any string. Are you clear? Every string, TM doesn't accept every string. TM maybe language is empty. Only if TM accepts a string, we can find out. We can find out only when TM accepts a string. That means no has a logic. S means every string rejected. How do you know that every string rejected? Every string in TM is rejected. So that we don't have a logic. Okay. So no logic for guys. Okay, I think you can't see this word. Okay, S has no logic. Remember that S has no logic. Okay, that means S has a no logic straight away, not REL. You can't build even Turing machine. When will you build Turing machine? At least S has a logic. Okay, if no has the logic also, then decidable. Alternate Turing machine you can design. Only no has a logic, then you don't have a Turing machine. Clear? Okay. Now this same problem, if I ask L is equal to TM, language of TM is not equal to pi. This one, yes I know, when you build it a logic, and S will have a logic, and no, logic doesn't exist. Just previous problem. Not empty means accepting some string. You can use a membership problem to verify on every copied TM. Thread concept, you can create the thread concept here. Thread concept can solve this problem using membership. Okay, S only has the logic. We know this is already undecidable, but now we know it is also semi-decidable because we have a Turing machine, but we don't have alternate Turing machine because Turing machine exists. But I can say clearly no HTM. I can say clearly it is not a recursive. I can say clearly not decidable. Not decidable, another name is only undecidable. Okay, this I can say recursively enumerable. Why recursively enumerable? Because it is semi-decidable. This is another name of SD. Guys, I'm keep on repeating the concepts to understand. Okay, guys, please, if you are learning something from me, please like the sessions and also share and subscribe, which is very important for us. Please spend 2 or 3 seconds for us. Please click on this video. Click on this video, like button. Please go to the like button and click on that. Thank you so much. I'm waiting for your likes. Okay, now 19. Now I'm changing the concept, guys. TM has 2 states. This is obviously trivial problem, guys. Why trivial? Here I don't need to run a Turing machine. Structure can verify the answer. Structure of TM can decide this answer. For that, we will never run a Turing machine, right? We will never run the given Turing machine. Structure of given TM can decide yes, I know, both. Because structure of Turing machine is always finite number of states. When you have the finite number of states, we will stop after some time. You can use a BFS or DFS, depth first search or breadth first search on this Turing machine. You can treat Turing machine as a graph. Finding the number of nodes in the graph is an algorithm now. Algo exists. It's going to take polynomial time, order of n time basically. Okay, this is a trivial problem. It is a decidable. How do you know decidable? How do you know L is decidable, guys? Because I can check whether given TM has 2 states or not. Has 2 states means I will give you TM, check S or no. No. S means we have 2 states. No means either less than or more than. Less than 2 or greater than 2 states. Obviously that I can understand because my algorithm always stops. Yeah. I may take half an hour more for this session. Mukesh, who is that? Ankit. Yeah. Now, similarly, trivial problems. A Turing machine where TM accepts recursively enumerable language, like semi-decidable language. I'm not asking which language, right? I'm giving just name. It's a theory, right? Is it trivial question or not? It is the trivial question. Why trivial? Because we know every TM in the world, every TM accepts REL. We no need to verify. That means every TM we are going to put blindly without applying any logic. So it's basically L is nothing but set of all TMs without any restriction. Everybody? Everyone? Is there any answer? No. Every TM produces S only. You ask any TM, you give TM, always answer is S only. Always. Why? Because no never happens. Never happens. Why never happens? Because every TM accepts REL. Never happens. Yeah. Clear? So this is a trivial question. It is decidable. Yeah, Mukesh, the previous question, let me clarify. You can collect the set of states now. Every individual state configuration only, right? The Q is always given. Q is given to you. It is given. If Q is not given, Turing machine is not given. Q is always given. Just to find the size of Q. Find the size of Q. Without giving the set of states, there is no Turing machine in the world for you. Yes or no, guys? Clear this point? Mukesh, when the machine is given, number of states is given. When number of states is given, just you need to find out how many states are there in the queue. You have given with Q, sigma, delta, Q naught, F, and blank and tau. All the parameters are given. Why this problem is decidable? Because Q is known, sigma is known. If not known, then Turing machine is also unknown. Clear this point? Everybody? Clear this point? Yeah, understand. Okay, now L is equal to Tm such that, yeah. So I'm going to take one question which was asked earlier. Tm accepts at most two inputs, two distinct inputs, both are same, guys. Two distinct inputs, distinct. Okay, before answering this, let me help you one question. L is equal to Tm such that Tm accepts only one string, means one input. Can you answer this question first before that? Tm accepts one string. To answer this question, I'm keep on going. Look at that, how many relations are there? Tm, language of Tm is exactly one string. Can you do this first? All the three are related, guys. This 23 you can reduce to 22, 22 you can reduce to 21. Everyone, guys, I'll keep on reversing. Everybody? Okay, Mukesh, you are okay. पहले अंडरस्टैंड करो गाइस, दुनिया में मैं ए स्टार नहीं पूछा, बी स्टार नहीं पूछा, मैं क्या पूछा? टीएम क्या एक्सेप्ट करता दुनिया में? हाउ डू यू वांट, व्हाई डू यू वांट टू वेरीफाई टीएम एक्सेप्ट्स आरएल और नॉट आरएल? बिकॉज वी नो टीएम नेवर एक्सेप्ट्स नॉट आरएल. क्यों वेरीफाई करना जरूरत क्या आपको? ऐसा कोई ट्यूरिंग मशीन है क्या दुनिया में नॉट आरएल करता? कम ऑन मुकेश, क्यों वेरीफाई करना है नॉट आरएल, है ना? Come on. Every Turing machine accepts REL. Then why do you want to verify not REL? अरे नोट करो यार, नोट करो. मैं पूछ रहा था, एवरी टीएम तो एक्सेप्ट ही कर रहा है REL. एवरी टीएम एक्सेप्ट्स REL. तो क्यों वेरीफाई करना है नॉट REL करता नहीं करता? एवरीबॉडी प्लीज हैव ए क्लैरिटी व्हाट यू आर थिंकिंग. यहाँ पे कुछ नहीं है, सिर्फ वर्ड ही है, डेफिनेशन ही है, राइट? You don't have a clarity in the definition what you are thinking about. Clear? यही तो है प्रॉब्लम. ऑलरेडी आपको आंसर पता है, हर टीएम दुनिया में एक्सेप्ट ही करता आरएल, क्यों वेरीफाई करना है? That's why we call trivial. क्यों? We don't have two types of Turing machines. Only one type of Turing machine that accepts REL. But मैं ऐसे पूछा, सपोज guys देखो अभी ये तो REL है. This is a finite language guys. This is the finite language. बट अभी नहीं कर सकते काम. क्यों? आप पर्टिकुलर लैंग्वेज दे रहा हूं ना. कुछ ऐसे ट्यूरिंग मशीन है एबी को एक्सेप्ट करता, कुछ ऐसे ट्यूरिंग मशीन है विच इज नॉट इक्वल टू एबी लैंग्वेज. बट प्रीवियस वन देयर इज नो ट्यूरिंग मशीन विच इज एक्सेप्टिंग नॉट आरएल. देखो दोनों का डिफरेंस क्या है, ये भी आरएल है वो भी आरएल है, बट वहां लैंग्वेज ने दिया या लैंग्वेज दिया, दोनों में डिफरेंस है नहीं गाइस, राइट? दैट इज इन जनरल, दिस इज अ पर्टिकुलर. ओके, right? If you have the questions, ask me, I will take that question. Every doubt is one problem. It may take 5 minutes, 10 minutes. I can't guarantee I will explain every doubt in this session. But Mukesh, you need to visit my every class to answer your doubts, right? Keep on posting your doubts. Okay. Language of TM is AB. Guys, to understand whether given TM accepts only AB, nobody else. What is the meaning of this problem? जिसको ये problem का name समझ में आता, then only you will accept, I will understand the given L. Whether the given TM accepts only AB, if this problem is decidable, then only L is decidable, because I need to apply this logic on L for every TM. S is what? No is what? S means TM accepts only AB. Now no means, guys, how do you understand, right? How do you understand other? No means it could be anything, that language is not equal to AB. L of TM, the no means L of TM not equal to AB. Means the L of TM, it means L of TM may be empty, or maybe epsilon, or maybe A star, doesn't matter. Maybe, epsilon comma AB. AB also there, but other string is there, then both are definitely not equal. Look at the problem, guys. You don't know which language it is. Now let's come to this point. Accepts only AB means, what is the meaning of this? It should alt at final. For AB. वो तो कर सकते हैं हम, but it should reject every other string. It should reject every string other than AB. How do you verify that? Can you have a logic for reject? That's impossible. Turing motion does not have a logic for rejection, because sometimes we will never halt. That is the reason yes has no logic at all. And what about no? Guys, emptiness already has no logic. If my Turing machine is accepting empty, you will also no logic. Both problems have a no logic. Now both yes and no will have no logic. This problem is strictly, directly not real. This problem is undecidable, we know that. But now we are saying not REL, means not semi-decidable. Because S has no logic. Yes has no logic. Everyone? So now because of this, now TM accepts only one string. That is only one string, guys. But do you have any logic? So because of this, this problem is undecidable. It is undecidable and not semi-decidable. I can say directly, it is not REL. Is that clear? So because of this, now at most two inputs, means it may be empty language, or it may be only one input, or it may have two inputs. Then already we know this has already not REL problem. Emptiness, guys. This is just now we have taken not REL and wo equal to be not REL honge. How do you know that only two inputs are accepted? This is also not REL. Even any one of them not REL, old problem is not REL. Yes, it's not REL. It is undecidable. That's what I'm saying. It is not SD. It is not SD. See, these three problems are interlinked. So if you want to answer 21, go for 22. If you want to answer 22, answer 23. So 23 is reducible to 22, 22 reducible to 21. Everyone, guys? Okay, now come to the point. Somebody is asking language. I'm trying to say TM, where TM does not accept not REL. Mukesh, it's your problem. Guys, I want to verify whether the given TM does not accept not REL. Yes, trivial. It never accepts now. That everybody know in the world. Everyone knows in the world. That is TM never accepts not REL. अगर नॉट आरएल को एक्सेप्ट किया तो नॉट आरएल आरएल बनेगा ना यार टीएम जो एक्सेप्ट करता उसी को नॉट आरएल उसी को आरएल बोलते। टीएम नेवर एक्सेप्ट्स नॉट आरएल। क्यों? एवरी टीएम एक्सेप्ट्स आरएल, ये तो सबको पता है ना। So this is trivial, this is also trivial, everybody knows in the world, that is why decidable। क्या आएगा? Right? Every TM does not accept not RL only, every TM। So collect, this is also set of all TMs only। Every TM does the same job। एक TM भी मिस नहीं होगा यहाँ पर। Every TM does the same job that you don't want to accept not RL, definitely that does। Yes, it is decidable, it is decidable because it is a trivial। There is no TM that accepts not RL। What is the conclusion? Every TM does whatever you say। Every TM not accepts not RL only because every TM accepts RL। That's true, that's true। Okay, 25th। Exactly, Sweta, that's you are true। Another way to say TM accepts RL। Now let's look at language accepted by TM is countable। तो ये नहीं पूछना गाइस एक काउंटेबल क्या है, तो एक क्लास ऑलरेडी होगा काउंटेबल के लिए। तो if you want just go and study my special classes, you already have the class। L of TM is countable, right guys? Whenever you are not able to understand any word from here, please visit my profile www.unacademy.com/@DevaGateCSE। You will definitely find a video for even countable, uncountable, only definition. You have 1 hour video. That means you need to know the concept clearly। So whatever I explained in 1 minute, if you don't understand, please go to my profile, then watch the video on this definition। And guys, you know why this is a trivial problem again? Because every language accepted by TM is countable। So we no need to verify this। This problem is also called as set of all Turing motions। It is trivial, so it is decidable। Everyone guys, it is decidable। But if I ask the question opposite, TM says that language accepted by TM is uncountable, ये भी trivial है। Why? There is no such TM, this is an empty language। Here L is equal to empty। Why? Because no TM accepts uncountable language। There is no TM in the world because every TM accepts countable। Everybody, so it is also trivial। We no need to run any algorithm on this। Directly you can bypass the algorithm to answer this question, that is decidable। Yeah, come on, keep on asking your questions। I will take your questions to answer guys। Okay, now very interesting language is going to come now। L is equal to finite language over sigma। And now you know every finite is what? Is regular। So I can say DCFL, I can say CFL, I can say CSL, I can say recursive, that is decidable। So I can say REL means semi-decidable, but don't say undecidable now, or don't say just undecidable because it's a very difficult word। You can say but that's not correct। If you say undecidable, you can't say undecidable। Undecidable means outside decidable, but this is already decidable, right? It is decidable। You can't say it is decidable। Now you can't say undecidable। You can say semi-decidable, but you can't say undecidable. Look at the problem word, guys. I have said semi-decidable, that doesn't mean undecidable, because semi-decidable are two types, decidable and undecidable. Every semi-decidable, don't say undecidable, that's wrong answer. Yeah. Yeah, there is one more question you have, Dilip. Okay. Let me take Dilip one more question. I didn't look at that. That is TM such that TM accepts. Your question only I am taking, one question already over. More than 2 inputs. It means TM such that language of TM, its size greater than 2. Greater than 2. Everybody, that means he is trying to ask one Turing machine. I have taken infinite Turing machines, but both are same. Whether given TM accepts more than 2 inputs, more than 2 strings. That means at least 3 strings. At least 3. More than 2 means at least 3. Okay, now we have to verify yes and no. Yes and no. Those people who can understand this problem, they can answer what is L. I'm not answering first L, I'm answering problem. Which one will have a logic? Guys, if suppose Turing machine accepts at least 3 inputs, तो आप thread concept लगा सकते हैं ना? Thread concept. Why? Same TM, create the threads. Copy TM here, same TM copy here. वो कॉपी करते रहो, बट लेकिन पहले एप्सिलॉन, देन ए, देन बी, then double A if it is over A comma B, and keep on doing it. Whenever the 3 times the Turing machine halts at final, then stop your concept. So S will have a logic. Yes will have a logic. But only the problem is, suppose Turing machine never accepts more than 2, then 3 never be possible to reach, right? 3 TMs, that means 3 copies. 3 threads. Whenever 3 threads halts at final, stop your concept. Halts at final, no need to verify because you got 3. 3 may be equal to 3 or more than or equal to 3. That doesn't matter. Greater than or equal to 3 you want. I will verify at least 3. Okay, no means, how do you verify no? It's impossible to say that Turing machine is not more than 2 means less than or equal to 2. Right? You can't verify b equal to 0, equal to 1 string, equal to 2. These are empty language and only 1 string, only 2 strings. These are already not real. No logic at all. No logic. Right? Yes, S has a logic. So that is the reason we have this problem is, even though it is undecidable, but it is semi-decidable. It is REL, that is SD. It is a recursive enumerable because of we have a Turing machine, because I can show that S has a logic, but I can't show you halting Turing machine is there because no has no logic. Yeah. Keep asking the questions if you have. Guys, please like this session. Okay, it's 28 problem. Now let me take my problem, guys. L is F such that F is finite. F is finite set over any sigma. Previous problem is something different. 27 was different. Guys, can you understand? L is finite set. L is set of finite sets. Both are different or not? Set of finite sets. L is finite set means you may have like, a power n. One example I am talking about. A power n, b power n less than 10. This is a one language. But set of finite sets means, guys, you have language F1, F2, F3, so many languages here. Like such L1s, so many, infinite are there. Like I can say A power n, B power n, where n less than or equal to less than 10, one language, and other language is, let's say epsilon, other language is A, other language is epsilon comma A. Such languages are infinite. Can you see the difference between these two first? Right? This is already I solved at 26. This problem is decidable. But what is this problem now? Set of finite sets. Yes means, guys, whether the given language is finite or infinite, can you decide? To understand whether given language is finite, can you decide first? No logic in the world. Why? Yes, I can say, but no way to prove. Yes means because you have the finite number of strings, your algorithm stops. Yes means language is finite, but infinite language can be not real. There is no way to say that the given language is infinite. There is no way to say that. But if it is regular, I can say that. If it is CFL, at least I can say that. But infiniteness, you can't verify for context sensitive and recursive language and recursive enumerable languages, guys. You getting my point? So infinite languages, you don't have a logic in the world, right? Sometimes you can have a logic, but not every time. So this problem is here. L is undecidable, but S has the logic. Yes has the logic, but no, there is no way to say the language is infinite. So no logic not exist for infinite languages. But some infinite is okay. But in general, you can't verify. This is semi-decidable. Why semi-decidable? Because you have a Turing machine. It's real. Yes. Clear this point? Yeah, 29 over, guys. Now keep on writing the same answers. Now L is, suppose I say regular language. One regular language over sigma. Can I say it's directly decidable? L is decidable because every regular is what? Decidable. I can say even L is CFL because every regular is what? Even I can say L is DCFL. Even I can say L is REL. L is REL, CSL. I can say semi-decidable, but you can't say undecidable, right? It is inside decidable class. Now, when I say L is equal to set of all regular languages, this time you are in danger. Why? First, do you know whether given language is regular? Regular you will know because you will have a DFA for that. Yes, definitely will have a logic because you can design a Turing machine. But no, what machine you will design? No, really, because not RL is also not regular. No logic to verify if the language is not regular. No logic exists because not RL, there is no logic to verify if it is not RL. Yeah, so this problem is also undecidable because set of regulars I don't have halting Turing machine, but one regular I can design halting Turing machine. Both are different, guys. It is semi-decidable because I can design a Turing machine for L. Semi-decidable means REL. So I can say simply this is REL but not recursive. Clear? 31. So I will copy paste all these problems. Just go and verify yourself. L is DCFL, deterministic context free language over sigma. Can I say L is directly DCFL? Trivial it is. Why trivial? Because one of the decidable only. L is decidable language. Because every language inside decidable class is DCFL. Is a decidable. DCFL is also one of the decidable. Trivial question. But when it comes to set of DCFLs, like I say D such that D is a DCFL over some sigma, then this is nothing but set of all DCFLs. This problem is non-trivial problem. Here L is undecidable problem. I don't know how to verify given language DCFL or not. Undecidable, but I can say L is REL because every DCFL have a logic. Yes has a logic, but no has no logic. Alright, so I can simply say L is REL but not recursive. That's the best name I can give to this language. Yeah. 34. L is equal to, and similarly L is CFL over sigma, context free language over sigma. Then trivially decidable, even I can say CSL, decidable language, trivial. This question is trivial. Okay. 35. If I say set of all CFLs over sigma, now this is a non-trivial problem. Now every CFL you have a logic, but not CFL you don't have a logic, so it is undecidable, no doubt, but it is semi-decidable, it is REL. So best answer is REL, that is a semi-decidable but not decidable, but not recursive. Recursive means decidable but not decidable. Okay, same question so far, keep on going guys. L is equal to, now if I say a recursive language, L is recursive, it's a trivial, purely trivial. Why trivial? Because recursive, another name only, decidable. It's a purely trivial now. Previously we were having different word, but now the same word, they are synonyms. But when it comes to L is equal to D, such that D is decidable language. Now this is not one decidable guys, it is a set of all decidable languages. Whether the given language, to answer this question, do you know first whether the given language is decidable? Whether given language is decidable? This problem you need to solve. Yes, if it is decidable, definitely you will have a Turing machine that always solves. Yes, definitely has a logic. But no, if not decidable guys, can you prove that I have some logic? There is no logic. Sometimes not real, I will give you, you have to say it is not decidable, but no way to say it is not real, because not real will not have a logic. So this problem is turns out to be undecidable. One decidable, you can say decidable, but set of decidable languages, is undecidable problem, but it is recursively enumerable, because every decidable you will have a logic. So it is REL, semi-decidable but not decidable, REL but not recursive. Okay, that's 37 and 38. Now this problem guys, L is equal to recursively enumerable language. I'm saying it is recursively enumerable language. And such questions never be asked in the exam, that's okay. Recursively enumerable language, is it decidable? L is just, now it is undecidable. You can't say this. First thing is recursively enumerable language, just word is given, not language guys, just word is given. Word is given, it can be either decidable. If I give you recursive, you can show the logic. There's no way to answer in general. There is no way to answer in general. Recursive enumerable can be either, it can be decidable or not decidable. Two types of languages are there. Particular language is given, then you can answer is it decidable or not decidable. But in general, no way to answer this question. So very, very difficult question guys. Recursively enumerable language is given to you, then that may be decidable or that may be not decidable. But this problem is undecidable to verify these two. Okay, I'm not answering this question, but this one, set of all RELs. It means set of all semi-decidables, semi-decidable languages. And do you know that in this, everybody, right, given L, whether given L is semi-decidable. Let's look at whether given L, whether L is semi-decidable. This problem you need to answer this language. Yes means L is semi-decidable. Means RL. No means L is not semi-decidable. Who will have a logic, guys? If it is semi-decidable, you have a Turing machine always. So logic exists. And not semi-decidable, you don't have a Turing machine. How will you prove that? No logic to prove. I don't have a Turing machine. No logic to prove. If I have a Turing machine, I can show you Turing machine. But when you don't have a Turing machine, what will you show? Impossible. No logic for no. But you have a logic. Logic exists for S. Because I can show you Turing machine. So S has a logic, no has no logic. Anyhow, this problem is undecidable. But because of S has a logic, I can say it is semi-decidable. What is the best answer is undecidable but semi-decidable, that is REL but not recursive. You can use the same word as SD but not D. Means I am trying to say SD but UD. Not D means UD. Everyone guys, 39. Come on, keep 40. Now, L is equal to set of all not RELs, not recursively enumerable languages. It is same as set of all not, not semi-decidables, semi-decidable languages. And you know, every not REL has no logic. If I want to say yes, no logic at all, but no will have a logic, guys. So anyhow, this problem you can understand directly. L is not REL. Look at guys, set of all not RELs is also one not REL. This is the beauty of the languages. Set of all not RELs is also one not REL, because you will never have a logic for L, right? Whether L is not REL, this problem, yes itself has no logic. Yes has no logic at all. Logic does not exist for S. So directly this problem is not RE. Okay, not RE. You can say undecidable, but this is the best word you can use. Right? Undecidable you can say, but don't say semi-decidable. I can say L is undecidable. But undecidable need not be not REL. Because of not REL, I am saying undecidable. Everybody clear? Previous problems are also undecidable, but they were semi-decidable. But this problem is not semi-decidable. This is not semi-decidable. Remember that. First, keep all the words in mind and keep the word definitions of those words. Then you can speak easily. Okay. Guys, please like this session if you are enjoying. That's very important for me. And L is equal to. I want to discuss this problem. Which one? Okay, I want to collect P1 comma P2, where P1 and P2 are two programs, C programs, let's say. P1 and P2 are C programs, and P1 is equivalent, logically equivalent to P2. Means both are doing same job. That is, if P1 is computing prime, P2 also computing prime. Something like that. If P1 is checking even number, P2 is also checking even or not. Now guys, this is equivalence of indirectly equivalent to two Turing machines. M1, M2, where M1 and M2 are Turing machines, and language of M1 equal to language of M2. This is purely undecidable, and also it is not semi-decidable. Remember that. Not SD. It's purely not REL problem, because there is no way to verify. Even though I am giving two programs which are equivalent, you can't prove they are equivalent because there is no algorithm to verify. Everybody, so look at that, how we are converting Turing machines to in general programs. Okay, next L is equal to M such that M accepts epsilon. What is mentioned? M is not mentioned. So by default, M what we take? Turing motion. When they don't mention about a motion, take as a Turing motion. You know, this M accepts epsilon. There are two problems I am saying. Note. If I ask, can you design a Turing motion that accepts epsilon? Yes, you can design. Why not? Yes, we can design. But the problem is not designing a TM that accepts epsilon. Can you verify? Given TM is already given. You don't know what it does. That accepts epsilon. That is undecidable problem. This is, if really accepts epsilon, you can. So this is undecidable. If does not accept epsilon, it's a membership problem, guys. It is the membership problem. It's just accepts any string is okay. No need to be epsilon. You can take A, B, membership problem. This problem S as a logic. If it accepts, you will have a logic because it halts at final. No, if it doesn't accept, logic not exist. I just told you in ABB string. Now it is epsilon. Both are same. But people had a confusion about epsilon, so I am talking about that specially. This is undecidable, but semi-decidable because S will have a logic. But semi-decidable. I can call it as recursively enumerable language. You can call it as recursively enumerable. But you can't call recursive because already undecidable. Okay. Now 43. You may have problems like, I'm talking about TM W comma 0. Before TM, let me talk about some D, where D is a DFA that accepts W. Then what is 0? 0 is just dummy statement. 0 is just dummy statement, guys. Okay, if you can't see, let me write it down. That accepts W. It's a dummy parameter in the triplet. So when you look at the language, how it looks like, okay, some motion is there. Okay, some motion is there. Don't worry what motion it is. Okay, some motion. This is a D. And some string will be there, like epsilon comma 0 always there. Okay, something, don't worry what is it. Okay, that's about DFA, so I need to take something like this. Okay, there is another DFA like D2 and let's say A comma 0, and W I can change based on my requirement. Okay, every input I can change my own W if I want it. That's okay. So you will have such language. So what is that? You need to build a logic where you get a parameter D comma W comma 0. That's your input, or simply D is given. That's also okay, and D and W is given. That's also okay. Now you need to say yes or no. Yes or no. Can you say or not? Right? Whether the given DFA accepts W or not. Obviously you can say you have a logic. Membership algorithm you can use. Membership algorithm on every input. On every input you can do that. Yes, you can say yes or no. That is the reason this problem is decidable. You can collect that. Right? Okay. Now L is equal to let's say L1 comma L2, where L1 is the CFL and L2 is regular, language, so that I'm asking a question, L1 intersection L2, L1 intersection L2, a new problem I'm designing right now. L1 intersection L2 is pi. This is my problem. So what is the meaning of that? You need to understand for every input what happening. So I am giving you a CFL comma regular language. Can you verify? CFL intersection regular is pi? Yes means CFL intersection regular equal to pi. No means CFL intersection regular is not equal to pi. Guys, what is the meaning of this? Do you know this problem is same as note? I'm writing a note that is CFL intersection regular. Do you know it is CFL always? Then only you can answer this question. And is the question similar to, is the CFL equal to pi? Because we have an algorithm to do the intersection of CFL intersection regular, guys. CFL emptiness problem is already decidable. Emptiness for context-free language is decidable. So this problem is also, L is also decidable. Look at that. How did I conclude decidable of a new problem, guys? Okay. Now 45. L is equal to FA1 comma FA2, where a language of FA1 subset of language of FA2. If two finite data is given, their languages I am verifying. You know, subset checking. This is decidable. Inclusion problem, guys. This is the inclusion problem. Set containment problem. Right, subset checking problem. This is decidable. So this problem is also decidable. Okay, similarly 46. L is equal to, I can talk about intersection is empty. Like I can give you FA1, FA2, two motions. I want you to verify L of FA1 intersection L of FA2 is equal to pi. It's a disjointness, guys. Indirectly, this is a disjoint problem. Disjoint problem, we are already solved that in the beginning of undecidability. This problem, disjoint for finite are decidable. Right? So we can say that L is also decidable. Decidable set. I can say because of decidable, I can say now even semi-decidable. I can say that if I want. Okay, so I'm just concluding how can you answer very easily most of the questions. Vishnuvardhan, from Monday we will continue the C classes. The L is now W such that length of W less than 100, where W belongs to A comma B whole star. What is this, guys? Is it decidable? Because it's going to be a finite language. When it is a finite set, every finite set is what? Regular. Every regular is what? Definitely decidable. Because I'm going to talk about decidable set or not. Yes, it is decidable set. It is decidable set because over strings, it is set of strings is, we know we have a DFA. So we have a DFA means we have a Turing machine, but this DFA you can build Halting Turing machine too. Okay, 48. L is equal to Tm such that Tm reaches state Q within 100 moves. Within 100 moves or steps are, right, it's basically transition based. The within 100 moves means just you need to verify 100 moves exactly. So you will never go to infinite loop. The machine always halts. Our logic always halts. Within 100 moves, how many configurations will be there? Finite configurations, finite paths in given Tm within 100 moves. Within 100 moves. How do you know that? Just take 0 move, how many paths? Exactly one path will be there. And 1 move, how many paths? 2 moves, how many paths? Just you need to go worst case 100 moves. So this is called as within 100 moves. Within 100 moves, we have only few paths in the machine. We never have infinite paths because our states are finite, our transitions are finite. So our paths up to 100 moves, we will have finite paths. So our logic always holds. Now, yes, how do you say yes or no? Whether Tm reaches state Q or not, look at the logic. Tm reaches state Q within 100 moves. I'm talking about one Turing machine. You can apply the same logic on every Turing machine in the world. Okay, yes and no. Yes means what? At least one path. Within 100 moves paths. Within 100 moves, at least one path. So within 100 moves, how many paths are there? Few paths only. Within 100 moves paths, at least one path, if it reaches the state Q, at least one path reaches the state Q, stop the algorithm, say we have a logic. Anyhow, we never go infinite. So logic exists. Yes means definitely you can reach. No means what you do? Every path, that means within every path that you verified up to 100 moves, within 100 moves, every path you verified. Every path within 100 moves paths never reaches or does not reach state Q. Does not reach state Q. If does not reach state Q out of all these paths, then stop the algorithm. Stop now. After verifying all the paths. Here also logic exists. We never go to infinite loop because paths are finite. Up to 100 moves finite paths. I'll verify every configuration up to 100 moves. Then I will stop the algorithm. So either case it halves. So it is a decidable. That means recursive language. That means even I can say REL because every recursive is REL. Yeah. Okay guys, last two problems. 49. L is equal to, if I say DCFL but not regular, even though I say DCFL but not regular, it is trivial. Why trivial guys? It is decidable. It is there in the decidable class, so you can say decidable language. Outside the regular, inside DCFL class, still it is a decidable language. But when I say L is equal to set of all DCFLs but not regulars, what you can say? Every DCFL you have a logic, but every not DCFL who is not regular. So look at that guys, complement. These are regulars and these are all DCFLs. Now what I have given, this is your L now, this is your L. Now when I do the S means that must be inside here, that language. No means either it can be regular or it can be not DCFL. So yes will have a logic, but no. If it is regular you will have a logic, but not regular, that is outside the DCFL, not DCFL, you will not have a logic. This is a not a DCFL, right? The L complement basically happens all not DCFLs union all regulars comes out. Even though all regulars have a logic, but all not DCFLs will not have a logic. That is the reason L is undecidable, even L complement too, but undecidable, this is semi-decidable. Because every DCFL which is not regular will have a logic. Everyone, but when you are talking about L complement, it is undecidable, it is also, but it is not REL. Okay, so please try to understand the first words, then please focus on the definitions, then so that we can understand these problems easily. And thank you so much and have a good day for you. And you can visit my URL to access all my classes. This is my special website where you can access all the Unacademy classes which are free or paid. and these are various we are conducting various sessions by these educators on this channel. Please attend these classes too, and thank you so much. Please like this session before leaving, and see you in the next class. Bye bye, take care. And if you are coming to the Unacademy, please use the code DEVALIVE to get 10% discount. You know that prices are going to increase soon, right? And prices also going to increase up to 40%, so that is huge amount. So better to join before 28th